C++ references are very much like pointers, but with different rules and different semantics. Here I have a working copy of working.cpp from chapter 5 of the exercise files. Let's take a look at a quick example, see what references are. I'm going to start by just declaring an integer, and I'll give it a value. And then I'm going to declare a reference to that integer, and that looks like this. The ampersand is what makes that a reference, and then I assign it a variable of the same type or an object of the same type. And that makes this reference bound to that object. And then I can use either the reference or the object in exactly the same way. I can say IR, and when I build and run, you'll see the value is 5. Or I can just say I, and we'll get an unused variable warning here. And it'll still say that the value is I. And in fact, if I change the value of IR, now the value of I is also changed. And so I can use IR just as if it were I. I can give it values, I can assign it to other things, I can increment it, I can pass it to variables, I can do whatever I want with it, and it will act just as if it were I. So a reference works very much like a pointer, but with obviously some significant differences. The syntax of setting a reference is different and does not involve using the address of operator. See, I didn't have to use the address of operator here when I set it. The syntax of getting the value referred to by a reference also does not involve using the value of dereference operator. So here I didn't need to use an asterisk like I would with a pointer. You cannot refer to the reference itself. That is, you cannot take a reference of the reference. You cannot have a pointer to a reference. You cannot have an array of references. And the reference cannot be null, it cannot be uninitialized, and it cannot be changed to refer to another variable. The reference, in essence, doesn't exist anymore syntactically. It just becomes exactly the same as using the variable itself. So obviously, this isn't a very effective use of a reference, so let's make an effective use of a reference. Most often, references are used with functions and object methods. And so I'm going to set up a function here. I'm going to have it return a reference to an int, and I'm going to have it take a reference to an int as its argument, and we'll go ahead and return I, and I will increment I before it's returned. And we don't need this here anymore, and I'm going to make this a function call. And now the interesting thing that happens here, actually I'm going to put in a couple more printfs. I'm going to print I before and after we call the function, so you can see what happens here. This is what's called an unintended side effect. And so when the function is called, it's called with a reference. This I now refers to this I. I can actually change this so that it's not so confusing, make this X instead. So this X is exactly as if we were using this I. So when I increment that X, this I gets incremented. And you'll see that it returns the incremented value, and the value of I is also incremented after the function call. So before the function call, it's 5. The function call returns 6, and the value of I is now 6 after the function call. And when you call this, there's nothing here in this function call that tells you that you're passing a reference. And so this is actually pretty dangerous. This is why most often when you see a function call like this, it will say const, and it will even return, if it's returning a reference, it will return a const reference. And so obviously I can no longer increment this. I need to use a separate variable, and it has to be static because I'm returning a reference. And now I can increment y, and I can return y, and we no longer have our side effect. So whenever you're using references, especially in function calls and class method calls, you always want to make them const, unless you really want side effects. And if you really want side effects, then I always suggest you use pointers instead of references, because then it's more obvious. You need to be aware, though, that not everyone agrees with my opinion on this. And there's a lot of code out there that uses non-const references, including quite a bit of the standard template library. So you just need to be conscious of this effect. References are very powerful and very common in C++. We'll be using references quite a bit, and you'll gain much more experience with them in the rest of this course.